So I'll be presenting our work on technical debt analysis through software analytics. One of the themes that you've been hearing throughout the morning is data. We pay a lot of data that is produced, consumed. We tend to forget the data that we produce during the software development process. So this is actually going to take that perspective and trying to analyze it from the understanding of can we actually utilize it better to better make decisions and in terms of both architectural trade-offs and cost-benefit trade-offs. So let me start with describing what I mean by technical debt. Although we've been at this for a number of years in varying concentrations, and the community actually has really rallied around it, especially tool vendors, there's still some misconceptions in terms of what we mean when we say technical debt. So it describes actually a universal software development phenomenon where you'd make some trade-offs for good reason or for bad reason in the short term, either to optimize delivery or to pick a particular technology, and then it has long-term consequences. If you react to those early enough, the rework cost actually is significantly less, or you might actually decide, you know what, I'm going to live with that cost. Its impact is not that significant on my project. So that's really what we're talking about when we're talking about technical debt. What is the problem? The problem is because we have so much cost put into our software, a lot of our stakeholders are now asking the question, I want to know what I'm getting. What is the technical debt of this project that I'm getting? So if we're talking about a contractor and owner relationship, or we have development teams asking each other, well, I'm making this decision now, how am I going to actually be able to communicate it to the rest of my team members? There are two very important aspects of these because over and over again, our empirical work has proven to us, as well as our analysis, is the most rework causing aspects and most costly aspects turn out to be design related, architecture related. And guess what? They're harder to analyze for. They also are a little hairier because they may have domain-specific aspects. So that's really the problem that we're going after. And how do you quantify the consequences brings back all that boatloads of data that we generate throughout the software development process, being able to analyze it. And that's what our solution is. Our solution approach is, well, can we develop actually a software analytics capability that helps us analyze technical debt? But it's not necessarily just in the code, because there are multiple artifacts that we can analyze and correlate and create causal relationships with each other and provide to the stakeholders, well, these are the areas maybe require attention before others. These are the areas might be okay to live with because that has extreme power in terms of making that cost-benefit trade-off. So that's where our solution is relied. And how we're doing this, we're bringing several techniques together, both borrowing from machine learning, refactoring and code analysis, and bringing some architectural expertise into that, and data mining in creating some of these items. So let me give an example, and I think this is a theme you've heard as well in the morning when our CERT director, Bobby, made the presentation as well. There's a relationship between security and operational quality as well as design and architecture quality. This is from an open source example. It's about a crash that has been happening in the software over and over again, and they've actually been able to identify its source. It's because of a large negative number, and it crashes. Of course, it has immediate problem because the software cannot function, so they need to fix it. But it also has an enduring issue because it creates security vulnerabilities even if it doesn't crash. But what happens in this scenario is this particular problem reoccurs. They patch, it reoccurs. They patch, it reoccurs. And at some point, one of the developers says, you know what, there's something going on here. Yes, there's actually something more fundamental going on here. That particular issue is injected every time an API call is made to an external library. They actually have to patch it at that location or negotiate a fix with that external component. They patch it about 16 times. The outreach of the software is quite a number of places. So that's a simple cost-benefit trade-off if you were to have the techniques to be able to locate the sources of those issues. So that's where our two-year approach comes into play. So initially, we're working on creating a technical debt classifier that we can intelligently collect some of these issues that might be going on systematically across the issue trackers or some of the qualitative artifacts that we can actually analyze throughout the time. And we're applying topic modeling algorithms to be able to see whether we can actually build a classifier that can help the development teams. You know what? This project has been going for 2 decades, and you have some of these lingering issues throughout, and they actually create a cluster, and you might be better off if you're treating them together rather than one-off. So that's really what the goal is there. And then the second piece is, well, the qualitative artifacts is one aspect, but at the end of the day, code is the reality. We want to be able to analyze it, and we want to be able to analyze it again beyond that particular negative integer number. What is going on is systematically that has more understandable value in terms of making the design trade-offs. So there we're using static analyzers, but with a twist. The twist here is, can we actually both analyze the existing capabilities of the static analyzers for their ability to detect some of these design concepts, as opposed to just syntactic issues at the code level, both of which are important, but how do we actually create these clusters where we can make more intelligent trade-offs and bring it back to a cost estimate perspective? And then can we create those clusters as particular aspects of detecting the technical debt issues and correlate them with some of the rework aspects of it? And once we have these different pieces of information, how do we actually consolidate them? For example, if I have a violation that says I have a logging error, when do I say, well, you really need to re-architect the system to figure out a better logging approach to your system? Or when do I actually decide to treat it in the syntactic level versus at the architectural level? And that's where the consolidation comes into play. And then the last piece is how to rank these issues together. And that's actually, this is a 2-year project. That's going to be coming together as we speak within the next year, because there are different pieces of the puzzle. Now, can we actually allow the developers or the acquirers to say, okay, can I actually now create a ranking, and does that ranking make sense for me to be able to allocate my resources to resolve some of those issues? So our progress to date has been mostly in working in different pieces of this puzzle, and I'm going to give you a little glimpse of these progress that we've had. So applying machine learning to technical data extraction from issue trackers. This is a piece of this that I'm actually quite excited about, because we see it systematically throughout. There are a lot of data that is generated, and are there actual generalizable aspects? The one part that's exciting here is the developers themselves, without anybody probing, within their discussion says, this is technical debt. We should come back to it. So that was one of the clues that got us thinking, there's something going on here that actually is in the knowledge of the experts, but we don't have the tools for them to be able to express it better. And when we manually inspect some of these projects, we do clusters of issues reoccurring that we would associate with this rework consequences and design trade-offs. Having seen this, we said, well, let's step back and see if we can apply some of these algorithms to build models, and whether these models will be able to help us in terms of identifying technical debt that over time, with the overload of information, developers may not be able to, but we could help them assess their software. So we're applying n-gram feature engineering techniques, which is as you build these weak classifiers in an iterative way, and they combine them and create more stronger classifiers. One of the, of course, gotchas of this work is, since this is a new area of work, existing know-how is limited. So we're also working with our team, and as well as our external collaborators, in creating exemplary issues where they would associate it with these rework consequences and technical debt. Our models are improving in several dimensions. One is we're able to actually recall, which means more technical debt is accurately is identified, and we're also able to identify most of the technical debt in our data sets. This is exciting progress, although there's a lot of data analysis and cleansing that goes on in the background, because we also have organizations who are coming to us and say, tell us when it's ready, because we want to apply, we want to be able to see that. So we're getting there. The second piece I'm going to give you a glimpse of it, is from the software quality analysis tools. This is actually important because we have a lot of quality, organizations looking in applying static analyzers into their systems with the hope that it's going to spit out their technical data or whatever problem areas that they should be resolving. So we looked into some of the most popular static analyzers out there to try to assess whether they have these design aspects already embedded in them that could help us identify some of these lingering issues. So first of all, yes, there is actually some already existing violation rules there that could be taken advantage of as design, but there's a lot of room for improvement as well. So our next step was, all right, let's apply this in actual projects and to see whether our clustering approach can, using what is already existing there, actually gets us a better result. So we applied it to 9 different projects, and actually our results are quite encouraging. First of all, one of the assumptions we have across the board is software maintainability and sustainability creates the cost overrun. Systematically, and no matter whether this is industry, open source projects, government projects, maintainability and sustainability aspects are rated low by the teams. If your software is complex but it's working, nobody cares. I don't know if you would agree with that or not, but that's what we observe. Nobody will give you money to fix it. You have to really demonstrate it with an operational capability, which makes sense, but that's actually where technical debt actually could be a very powerful tool, because you could say, you know what? Yes, I really don't care because I cannot map it to security or operational performance, and it's okay for it to live there if I don't see that cost trade-off. So that's what we're observing. Another thing what we're observing is we can actually identify these trade-offs. The first violation there is about 300. It comes from one project. That one project has to really re-architect for logging. On the other hand, the second, the red ones that you see there, is again from one other project, but there we're talking about less in magnitude, yet it's really significant because they're creating these security and performance issues. So this is to give a glimpse about the kind of analysis we're bringing to bear and how we're combining it. What it does is it really reduces the complexity of the information that the teams get. And through that, you're able to make better choices in terms of where you should spend your resources to be able to do those rework decisions. I'm going to go through this very quickly. We work with a lot of organizations across the board. One thing we're very excited about is because of the progress we were able to accomplish, actually we were approached through a lot of academia, tool vendors, and industry to launch a conference on technical debt, and the very first conference will be co-located next year in 2018 with the International Conference on Software Engineering. So we're very proud of the progress that we're collectively making as a community. I think I have like either 0 or 1 minute, so I'm going to close it very quickly. We think technical debt is going to be there forever, especially now we're creating more complex systems, machine learning systems, data uncertainty, data creates a level of uncertainty, so we really need to put some of these techniques to use in how we're creating the software so we can get more intelligent there. With that, we have a great team, and maybe I can take one question.
So the definition of technical debt is always kind of interesting and is based on having quality metrics that can be applied uniformly. Those metrics do not seem to really exist at this time in a concerted and canonical fashion. Where does your team stand on establishing a set of metrics that could be considered canonical and ubiquitous for this type of measure?
In terms of metrics, the position we take is using tools to create those metrics in context for these projects. Because if you have a very, for example, long-term project that you deal a lot with legacy, then maintainability metrics might actually be the ones that take higher priority. Whereas if you're in a very vulnerability-prone and security environment, then maybe those metrics might change in that context. There are some ubiquitous ones across the board that we observe, and I'm happy to talk to you about them in detail because there are different categories. Some of them are emerging, but our position is if we already know those, we should also put other tools to bear so that they should be fixed as they're occurring rather than being caught in retrospective. I'm out of time, I think. 0. Oh, well, you had a question.
Well,
Sarah.
it's sort of related. When I buy a house, I have an inspector come and tell me all the things that are going to cost me money in the future. Can we provide that kind of inspection, or are we working towards a way for anybody buying software to get that kind of a
Inspection?
Accounting?
So that's what our stakeholders want. Whether we get there or not, I think, is also an aspect of how much domain specificity influences that inspection. But again, there are criteria, and we should definitely be able to create the criteria to get there. So the next speaker is Bill Novak, and he's going to be talking about some of the game theoretic approaches that we bring to cost-benefit analysis. Thank you.